Welcome, fellow explorers! Today we're uncovering 10 astonishing secrets about our home planet that will change the way you see Earth. When we think of Earth, we often picture it as a perfectly round sphere, a smooth blue marble suspended in the vastness of space. It's a simple, elegant image that's easy to grasp. We see globes in classrooms and digital representations online, all reinforcing this idea of a flawless sphere. But in reality, our planet is far more interesting and complex. It's not a perfect sphere at all, but rather an oblate spheroid, a slightly squashed sphere. This subtle yet significant difference reveals a great deal about the forces at play within our world. This means that Earth is slightly flattened at the poles, like a ball that's been gently pressed down from the top and bottom. This flattening isn't dramatic, but it's enough to make a measurable difference in the planet's overall shape. And conversely, it's bulging at the equator, creating a gentle outward curve around the middle of the planet. This bulge is a direct consequence of the forces acting upon our rotating world. This unique shape is primarily caused by Earth's rapid rotation on its axis. Our planet spins at an incredible speed, completing one full rotation approximately every 24 hours. This constant spinning motion has a profound effect on its shape. As Earth spins, it generates centrifugal force, which pushes material outward, away from the axis of rotation. This force is strongest at the equator, where the distance from the axis is greatest, causing the equatorial bulge. The equatorial diameter, measured around the equator, is about 42 kilometers greater than the polar diameter. This difference might seem small compared to the Earth's overall size, but it's a significant deviation from a perfect sphere. The pole-to-pole diameter, measured from the North Pole to the South Pole, is shorter due to the flattening effect of Earth's rotation. This difference in diameter is a key characteristic of Earth's oblate spheroid shape. This bulge means that if you were to stand at the equator, you would be slightly farther from Earth's center than if you were standing at either of the poles. It's a subtle difference, but a real one. So, you're not just standing on the surface, you're also a little further out in space. This seemingly small detail has some surprising consequences when we consider the highest points on Earth. Mount Chimborazo in Ecuador, a majestic peak in the Andes Mountains, owes its unique distinction to this equatorial bulge. Its location near the equator gives it a special advantage. Because of the bulge, the summit of Mount Chimborazo is actually the farthest point from Earth's center, even though it's not the tallest mountain above sea level. This means that Chimborazo's peak is farther from the Earth's core than the summit of Mount Everest, the world's highest peak above sea level. It's a fascinating fact that highlights the difference between height above sea level and distance from the Earth's center. This subtle shape of our planet affects everything from sea levels, influencing ocean currents and coastal patterns around the globe. The oblate spheroid shape also plays a crucial role in determining the orbits of satellites, requiring precise calculations to ensure their accurate positioning and functionality. Our planet's form, therefore, is not just a static feature, but a living record of the powerful forces, gravity and rotation that constantly shape and mold it, influencing everything from the heights of mountains to the paths of satellites. Deep inside Earth, a hidden world churns. It's a realm of immense pressure and unimaginable heat, where the very building blocks of our planet are forged in a crucible of energy. This dynamic environment is the engine that drives one of Earth's most vital, yet often overlooked features. Within this fiery core, molten iron swirls and eddies, creating powerful electric currents. This movement, driven by the Earth's rotation and the intense heat from within, generates a magnetic field that extends far out into space. It's a natural dynamo, a planetary powerhouse working tirelessly beneath our feet. This magnetic field acts as an invisible shield, a vital defense that protects us from the constant barrage of charged particles emitted by the sun, known as solar radiation. Without this shield, the solar wind would strip away our atmosphere, rendering Earth uninhabitable. But this field isn't fixed or static. It's a dynamic entity, constantly shifting and changing in response to the turbulent activity within Earth's core. The strength and shape of the field fluctuate over time, influenced by the complex interactions of molten iron deep below. One of the most noticeable manifestations of this dynamism is the movement of the magnetic North Pole. Unlike the geographic North Pole, which is fixed, the magnetic North Pole is constantly on the move, wandering across the Earth's surface. For centuries, the magnetic North Pole resided comfortably within the Canadian Arctic. However, in recent decades, it has been steadily drifting eastward, heading from Canada toward Siberia. What's even more remarkable is that this drift isn't happening at a constant rate. Instead, the magnetic North Pole is moving at an accelerating pace, picking up speed as it journeys across the Arctic. And the story doesn't end there. Sometimes, over vast stretches of geological time, Earth's magnetic field undergoes an even more dramatic transformation. It even flips, reversing its polarity entirely. During these reversals, the magnetic North and South poles effectively swap places, a phenomenon that has occurred numerous times throughout Earth's history. It's a planet-scale reset button for our magnetic field. The evidence for these magnetic reversals is preserved in the very rocks beneath our feet, a process recorded in ancient rocks. As molten rock cools and solidifies, magnetic minerals within align themselves with the prevailing magnetic field, creating a permanent record of its orientation at that time. These magnetic reversals aren't quick events. They don't happen overnight. Instead, these reversals take thousands of years to complete, a gradual process of weakening, shifting, and ultimately, flipping. During the transition period, as the magnetic field weakens, our planet becomes more vulnerable and can weaken the field to the harmful effects of solar radiation. The shifting magnetic field also has practical implications, affecting navigation systems that rely on accurate magnetic readings. Compasses may become unreliable, and electronic navigation tools may require adjustments. Furthermore, many animals, including migratory birds and sea turtles, rely on the Earth's magnetic field for navigation and animal migration. Changes in the field can disrupt their natural instincts and migratory patterns. Given the accelerating pace of the magnetic North Pole's movement, today's rapid pole drift presents a challenge for maintaining accurate navigation systems. To compensate for these changes, navigation systems must be updated regularly, ensuring that our technology remains aligned with the Earth's ever-shifting magnetic landscape. Our magnetic field is a dynamic, ever-present force, a testament to the powerful processes occurring deep within our planet. It's an ever-changing force, a reminder that the Earth is not a static sphere, but a living, breathing planet. It's a window into the restless heart of our planet, revealing the hidden forces that shape our world. It's a reminder that even the seemingly stable features of our planet are subject to change. It's a reminder that even the ground beneath our feet, solid as it may seem, is part of a dynamic system. It's a reminder that even the continents themselves are in constant motion, drifting across the Earth's surface over millions of years. So the next time you use a compass to find your way, or rely on a GPS system to guide you, remember? Take a moment to appreciate the invisible force that makes it all possible. Earth's magnetic personality is always evolving, a testament to the dynamic and ever-changing nature of our planet. We often credit rainforests, those sprawling emerald canopies, for being the lungs of our planet, the primary source of the very air we breathe. And while they certainly play a crucial role in maintaining our atmosphere, there's another, perhaps less obvious, contributor that deserves just as much, if not more, recognition. It turns out that the real heroes, the unsung champions of oxygen production, are the microscopic phytoplankton teeming in the vast expanse of our oceans. These tiny organisms, often invisible to the naked eye, are the true powerhouses behind Earth's breathable atmosphere. These tiny organisms, single-celled plants and bacteria, drifting in sunlit waters, soaking up the sun's energy, produce up to 85% of Earth's oxygen through the remarkable process of photosynthesis. They are the foundation of the marine food web and the primary drivers of oxygen production on our planet. Every other breath you take, that life-sustaining gasp of air, comes from these invisible ocean dwellers, these microscopic marvels working tirelessly beneath the waves. Phytoplankton blooms, massive gatherings of these organisms, can be so vast, they're visible from space, painting the ocean's surface with swirling hues of green and blue, a testament to their sheer abundance and productivity. Their health is vital. It's not just about the oceans, ocean warming and pollution. The relentless tide of plastic and chemical runoff threaten their survival, disrupting their delicate ecosystems, and thus our own. The consequences of their decline would be catastrophic for the entire planet. The fate of these microscopic plants, these tiny engines of life, is directly tied to the air we breathe, to the very rhythm of life on Earth. Protecting our oceans, safeguarding these vital ecosystems, means protecting our very breath, ensuring the health of our planet, and securing a sustainable future for generations to come. It's a responsibility we all share. Our moon may not have always been alone. Some scientists believe Earth once had a second, smaller moon, formed from the same colossal impact that created our current moon. This companion likely collided with the larger moon, merging and leaving behind the mysterious differences between the moon's near and far sides. The story of our moon is a tale of cosmic collisions and lost companions. The driest place on Earth isn't a desert of sand, but Antarctica's McMurdo Dry Valleys. Here, it hasn't rained or snowed in nearly 2 million years. Powerful winds and mountain barriers keep moisture out, creating a landscape drier than the Sahara. Yet life persists. Microbes survive in rocks and soil, making this region a model for studying life on Mars. The dry valleys are a testament to life's resilience in the harshest conditions. Sometimes, the most extreme environments are hidden in plain sight. Earth's rotation is slowing down, making our days ever so slightly longer. The culprit? The moon's gravity, which creates tides and drags on Earth's spin. Each century, our day lengthens by about 2 milliseconds. Hundreds of millions of years ago, days were much shorter, just over 21 hours. As Earth slows, the moon drifts farther away, changing our sky over eons. Fossil corals and ancient rocks record this gradual change, revealing Earth's deep time rhythms. Our planet's dance with the moon is a slow waltz, shaping time itself. The hottest air temperature ever recorded wasn't in the Sahara, but in Death Valley, California, 56.7 degrees Celsius, 134 degrees Fahrenheit, in 1913. Death Valley's low elevation, trapped air, and sun-baked rocks create a natural oven. Its arid landscape absorbs and radiates heat, pushing temperatures to extremes. Despite its name, life endures here. Plants and animals have adapted to survive. The world's hottest places aren't always where you expect. Earth's extremes are shaped by unique combinations of geography and climate. Earth's atmosphere stretches much farther than you might think, well beyond the moon. The outermost layer, the geocorona, is a cloud of hydrogen atoms extending over 630,000 kilometers from Earth. This means the moon actually orbits within Earth's atmosphere. The geocorona is incredibly diffuse, but it's a real, measurable part of our planet's reach. Even in the emptiness of space, Earth's influence lingers. Our atmosphere is a ghostly halo, connecting us to the cosmos. The Milky Way contains up to 400 billion stars, but Earth has an estimated 3 trillion trees. That's about 8 trees for every star in our galaxy. Trees are vital. They produce oxygen, store carbon, and support countless species. But their numbers are shrinking due to deforestation and human activity. Our forests are more abundant than the stars, but they need our protection. The fate of our planet's trees is in our hands. Gravity feels constant, but Earth's gravitational field is actually lumpy and uneven. Mountains, ocean trenches, and hidden underground features all cause subtle variations. Satellites like NASA's GRACE mission map these anomalies, revealing details about Earth's interior and changes in water and ice. These gravity bumps help scientists track melting glaciers, groundwater loss, and even improve GPS accuracy. Our planet's gravity is a patchwork, shaped by its dynamic geology. Even the force that keeps us grounded is full of surprises. Earth's complexity runs deeper than we can see. Our journey through Earth's hidden wonders reveals a world more dynamic and surprising than we ever imagined. From the shape of our planet to the reach of its atmosphere, each fact deepens our connection to this extraordinary home. Which of these secrets amazed you most? Let us know in the comments and keep exploring with us.